Tropical cyclones are perhaps the most incredible natural wonder on the planet. Nothing else matches tropical cyclones in terms of their structural complexity at their size and intensity. A perfect set of conditions are required to make the strongest cyclones, yet these conditions are becoming more common as the Earth warms. So that leaves the question, how will a warming climate impact climatology, frequency, and hazards relating to tropical cyclones? Why is it important to research and study how a warming climate will affect tropical cyclones? Because it's already affecting people. Climate change affecting hurricanes isn't some far-fetched idea that we're decades away from. It's already occurring and causing increased death, damage, and destruction. Let's look at a couple examples. Hurricane Otis formed on October 22, 2023 in the East Pacific Basin off the coast of Mexico. It was supposed to just meander northward and be near the coast as a tropical depression. Exactly 24 hours out from landfall, it was supposed to be a tropical storm. 24 hours later, Otis became the first landfalling Category 5 in the East Pacific. Hurricane Otis made landfall as a practically unwarned Category 5 hurricane on a major tourist destination with a population close to 1 million people. Hollywood couldn't have scripted a worse situation if they tried. Why did this happen? Unseasonably warm temperatures in a part of Mexico that doesn't usually get strong tropical cyclones, as well as possibly the worst weather model miss of all time. No model showed the rapid intensification that would occur. Hurricane Milton formed on October 5, 2024 in the western Gulf of Mexico, moving east. With record sea surface temperatures below the storm, Milton exploded in intensity, becoming the first storm in the Atlantic with a sub-900 millibar pressure since Hurricane Wilma in 2005. The storm peaked with winds of 180 miles per hour. After the storm weakened during an eyewall replacement cycle, Milton intensified to Category 5 status. Thankfully, due to a sharp increase in wind shear, Milton weakened to a Category 3 before landfall. If Milton had made landfall 50 miles north, it would have taken a direct hit on Tampa Bay, becoming the most destructive hurricane on record, in terms of cost. Tampa ended up on the side of the storm with offshore flow, so it was spared the worst of the storm surge as well. The situation could have been so much worse if a few things went slightly different. Hurricane Melissa formed on October 21, 2025 in the Eastern Caribbean moving west. Melissa took some time to get itself organized, but once it did, it simply didn't stop. Hurricane Melissa, which only occurred a couple weeks ago, became the third strongest Atlantic hurricane on record and brought the most intense landfall in the Atlantic Basin in recorded history to Jamaica. Unlike most strong hurricanes, Melissa never went through a full eyewall replacement cycle. It maintained its Category 5 status for over 30 hours until it made landfall in Jamaica at peak intensity, meaning it was still strengthening. Melissa passed Milton in intensity with sustained winds of 185 miles per hour and a minimum central pressure of 892 millibars. Extensive postseason analysis will be conducted this winter to determine if Melissa was the strongest Atlantic hurricane landfall in recorded history.
So, how do different groups of researchers research tropical cyclones? Many different research disciplines use different but similar approaches to deep dive certain aspects or knock-on effects of tropical cyclones. We'll start with meteorologists. Meteorologists use field observation, modeling, simulations, and case studies to analyze how tropical cyclones are changing in a warming climate. Field observation is what Hurricane Hounds does. Computer models and simulations use complex mathematical formulas to try and predict shifts in tropical cyclone climatology, as well as some characteristics such as forward speed and rainfall totals. Case studies are similar to what we did above, looking at previous examples of tropical cyclones being affected by the warmer ocean and climate, but on a much more detailed level. Marine scientists use field observation, as seen with Hernandez Delgado's research, analyzing the health of coral after strong tropical cyclones pass through. Marine scientists additionally measure other factors such as fluctuations in salinity and phytoplankton growth with certain species, as an overall indicator to the impact of marine life in bays and estuaries, as analyzed during the landfall of Hurricane Irma. Statisticians use statistical analysis to analyze the frequency of tropical cyclones and the possibilities, or statistically speaking, how unusual certain tropical cyclone intensity rates are. Earth scientists use geological surveying and satellite imagery to study the effects of stronger tropical cyclones on the land surface. For example, how land erosion in certain places may change when subject to a stronger than usual hurricane at an increased rate. And finally, engineers use computer and physical models to study how building codes may need to change in order to keep up with the increased force they may be subject to. They design and implement countermeasures, aerodynamically building houses to withstand increasing hurricanes, reduce wind pressure, building flood vents to relieve water pressure, and much more. Many other groups such as biologists, social scientists, and others may be involved, as well as to further our understanding on how stronger tropical cyclones will affect other systems in play. Proper collaboration is required to adequately study not just how tropical cyclones will change, but how stronger tropical cyclones will affect many other factors and systems.
How does the popular media and peer-reviewed research differ in what they bring to the public? Most sources present the data reasonably with minimal sensationalism, however, not all. One of the biggest misconceptions is that both tropical cyclone frequency and intensity will increase. However, this likely isn't the case. More recent research suggested that the frequency of tropical cyclones may actually decrease due to the separation of tropical cyclone ingredients and a degradation of quality of tropical waves coming off the African coast. However, the average intensity of tropical cyclones in the community of rapid intensification events will likely increase dramatically. This means fewer tropical storms, but more hurricanes and major hurricanes. Another factor that should be discussed is the prevalence of the idea that the weather, particularly tropical cyclones, can be manipulated, spawned, and directed. This is not even close to possible. Hurricanes are so strong and produce so much energy that even a nuclear bomb wouldn't put a dent in a fully mature major hurricane. All that would occur is a radioactive fallout mess spread around by a hurricane. So let's not try that. In conclusion, tropical cyclones are wonders in nature that are getting stronger as a result of warmer climate. This brings an increased threat of death, damage, and destruction to coastal and inland areas, as well as many other threats that continue to be further researched. Many different research disciplines use their own skill set to further our understanding of the effects of stronger tropical cyclones.